Hello dear learner, welcome back to the Zoom Chemistry Hub. Today with another interesting and informative video in which we will discuss a most important topic in organic chemistry, that is hybridizations. So first, what is hybridization? Hybridization is the process of mixing atomic orbital to form new hybrid orbital with different energy and shapes will depend on the number of sigma bond and the lone pair around the central atoms. Next, we will discuss first sp3 hybridization. That is, in the sp3 hybridization, the geometry is tetrahedral of the molecule. Now we can define what is sp3 hybridization. As the name indicate, S and p3, 1s and 3p orbital mixed to form 4 neo hybrid orbital, that is 4sp3 hybrid orbital are formed. 4sp3 hybrid orbital are formed, and these orbital are tetrahedrally arranged with an angle of 109.5 bond angle. Example: sp3 hybridization occur in methane molecule CH4. Its structure is tetrahedral, and in this molecule the central atom is the carbon. Here is like this, the central atom is the carbon, and there are 4 sigma bond with hydrogen in CH4, that is each, that is carbon form 4 sigma bond with hydrogen atom, that is S and sp3. The hybridization is ethane molecule, ammonia molecule and water molecule have sp3 hybridization. Next type of hybridization is sp2 hybridization. In the sp2 hybridization, the geometry is trigonal, that is like this, a central carbon atom, and in this each bond have 120 degree of angle. So first we will discuss what is sp2 hybridization. A hybridization in which 1s and 2p orbital mix to form 3sp2 hybrid orbitals, and in the carbon the remaining unhybridized hybridized orbital form the pi bond in double bond, and the angle is 120. And when we take the example of sp2 hybridization in ethene, that is ethene molecule, in the central atom is the carbon, and the one bond is sigma and one is pi. Here you can see in the double bond one is sigma bond and that is sigma bond, and the other is pi bond. Other examples of sp2 hybridization which is occur in benzene molecule, boron trifluoride and formaldehyde, molecule. These molecules contain sp2 hybridizations. Next type of hybridization is the sp hybridization. sp hybridization having the molecule linear geometry or linear structure, and we can define the sp hybridization as when one s and one p orbital mix, they form two sp hybrid orbital. If we take the carbon atom in the remaining two unhybridized orbital, that is these are the p orbital, form two pi bond in the triple bond, and the bond angle in sp hybridization is 180, that is the linear structure. And when we will take the example of sp hybridization in its acetylene molecule, the structure is linear, that is acetylene it is hydrogen atom. On both sides of the carbon atom, one hydrogen atom is present, and in this molecule you can see that there is a triple bond. In this molecule, one bond is sigma and two unhybridized orbital contain pi bond. So one sigma bond is present in the triple bond and two pi bond in carbon triple bond. Other example of sp hybridization which are occur in the molecule, that is BCl2 barium chloride and carbon dioxide. These are the inorganic molecule. Next type of hybridization is the sp3d hybridization, and sp3d hybridization, how can we define these? When as an sp3d 1s 3p and 1d orbital mix together to form 5 sp3d hybrid orbital, that is 1s 3p and 1d. They form 5 sp3d hybrid orbital, and in this molecule which contain sp3d orbital, they have bond angle 90 and 120. Now we take the examples of sp3d hybridization which is occur in the phosphorus pentachloride PCl5. It is trigonal bipyramidal structure, and in this molecule the central atom is the phosphorus, that is phosphorus, and that is chlorine atom, and the 5 sigma bond is present between the phosphorus and chlorine atom, that is sp3d hybridization. Other example of sp3d hybridization are pf5 phosphorus pentafluoride and sf4 sulfur tetrafluoride. They have also the sp3d hybridization. Next type of hybridization is the sp3d2 hybridization. And in sp3d2 hybridization, the geometry is octahedral structure or octahedral geometry. Definition: as sp3d2, we count how many orbitals are participate: 2d, 3p and 1s. So 6 atomic orbital participate in the sp3d2 hybridization, that is 1s, 3p and 2d orbital mixed to form 6 sp3d2 hybrid orbital. And here the molecule which have sp3d2 hybridization have the bond angle is 90°. Now we take the examples: sulfur hexafluorides SF6. It is octahedral structure. The central atom is sulfur and the bond 6 sigma bond are present. That is, the central atom is the sulfur and the 6 sigma bond are present. 1 2 3 4 5 6 sigma bond are present with sulfur atom. Other example of sp3d2 hybridization is hexafluorosilicates ion and molybdenum carbonyl. Now we review all these. That is the key takeaway. sp3 hybridization have 4 bonds, that is 4 sigma bond, and its structure is tetrahedral. sp2 have 3 sigma bond, structure is trigonal planar. sp have 2 bond, structure is linear. sp3d have 5 bond, have trigonal pyramidal structure, that is PCl5, and sp3d2 hybridization 6 bond are present and the structure is octahedral. That's for all today, the learners. If you have any query, do write me in my comment box regarding the video or regarding the lecture. And if you like this video, please like, subscribe and share with your friends and fellows so we can grow each other. Thanks for watching. Goodbye.